Okay, so in this last video we were discussing about how white light was dispersed into the 7 colors, what we call spectrum, for the first time, what were the experiments performed for this purpose, and how Newton proved that the prism does not produce any color of its own. I also discussed an idea of a crucial experiment, and this is the experiment I was talking about. So when people were criticizing that the prism produces the 7 colors on its own, white light is white in color, Newton said, well, no, see, if I place a prism in this case such that it produces the spectrum, and then if I allow that spectrum to be incident on a second prism with its base inverted with respect to the first prism, ultimately the emergent ray, they all converge together to come out as the white light which was initially incident upon the prism. So this proved beyond doubt that prisms do not produce any color of its own. It is just simply a matter of refractive indices, the angles of the prism, and the speeds of light in different refractive mediums, as a result of which these 7 colors are produced. And it also proved one thing, that white light does consist of 7 colors, as I said, polychromatic in nature, but in our daily life we seldom see that. But as in the case of a rainbow, when this kind of refractive mediums are indeed present, in the case of a rainbow the raindrops act as small prisms, we get to see the 7 colors. Now that is all about the experiment. Let us deal a little bit about the theory. So consider the prism here. A ray of light of any arbitrary color is incident at the first surface of prism with an angle of incidence I1. The angle of refraction is R1 and the angle of deviation is del 1. It travels and then emerges out of the prism. The final angle of deviation at the second surface of the prism is del 2, and the total angle of deviation delta is equal to delta 1 plus delta 2. Now on what factors does this deviation depends? The angle of deviation that the light suffers as the first surface of the prism. Remember, delta at the first surface depends on 2 factors. Number 1, angle of incidence I, and number 2 is the refractive index of glass with respect to air, provided the prism is made of glass. And then there, as we see, there is a second deviation, a deviation at the second surface. So delta at the second surface depends on 2 factors again. The angle of the prism A and the refractive index of air with respect to glass, because now the light is traveling from glass to air. At the first surface light was traveling from air to glass, so it depended upon the refractive index of glass with respect to air. Now it is traveling from glass to air, so it depends on refractive index of air with respect to glass. And these 2 deviations cumulatively produce the total deviation delta. This is the deviation that any light ray suffers, and lights of different colors suffer different deviations. Violet, as I said, is deviated the most and red is deviated the least. Let us prove that using the formulas. We know a formula that refractive index of any medium 2 with respect to 1 is equal to mu of 2 by mu of 1, and that is equal to v of 1 by v of 2. That is the velocity of light in the first medium divided by the velocity of light in second medium. So in this case, mu of prism with respect to air is equal to velocity of light in air divided by the velocity of light in prism. Now the velocity of light in the prism shall depend upon the refractive index of the prism. If the refractive index of the prism is mu, the velocity of light in the prism for the different colors will depend on mu. Now we know another thing, that mu is sine of I divided by sine of R. You know from your previous knowledge that the refractive index of violet light is greater than the refractive index of red light for any medium. Therefore, mu violet is sin I by sin R violet, and mu red is sin I by sin R red. I remains the same because when the light is incident, it is incident in the form of white light. So all the light is incident in the first surface at the same value. So we see, since mu v is greater than mu r, sine of r for violet should be smaller than sine of r for red. This quantity sin I is constant, mu v is a bigger quantity. So to get a bigger quantity, you need a smaller denominator. Sin RV is smaller than sin R red, which implies that the angle of refraction for a violet light is smaller than the angle of refraction for red light. We know now the formula from the previous diagram of deviation. We saw geometrically that deviation is equal to I minus R. Therefore, the deviation of violet is I minus R of violet, and deviation of red is I minus R of red. Now since R of red is a bigger quantity, when we subtract a bigger quantity, the final answer is smaller quantity. Therefore delta red is smaller than delta violet. As a result, in the prism that we did in the first lecture itself, when the light travels, violet has a bigger deviation, so it comes towards the base of the prism. Red has a smaller deviation and it travels at the upward part of the prism, because ultimately when you calculate the deviation with respect to the initial direction of the incident light, this is the value delta V and this is the value delta R. So delta V greater than delta R, and we see that the observations in the experiment actually matches with the theory and the mathematics. So this was all about the dispersions mathematically. Now what is the cause of the dispersion? Now we drew this initial diagram of a prism and a ray of light falling on the prism. Such that the lowest most ray is the violet color, the uppermost is red, and in between are the other colors. Now what happens to these colors of the different wavelengths, due to which it spreads into the band we come to know as spectrum? And the reason is that when white light is traveling in air, remember, in air or in vacuum, all the wavelengths of light has got the same speed, and that is 3 times 10 to the power 8 meters per second. But when it enters in a refractive medium, like in this case glass, light which has got the longest wavelength shall be deviated the least, that is red, and light which has the smallest wavelength, like violet, will be deviated the most, because we had done a relation that the refractive index of any medium is related to the wavelength in this manner, and the name of this relation was Cauchy's relation. So we know that greater the wavelength, smaller is the mu for that medium. So greater the wavelength in this case is red, smaller the mu for red, smaller is the wavelength for violet, greater is the mu for violet. And if for any medium the refractive index is high, that means in that particular medium the speed of that particular light will be smaller, because again mu is equal to the absolute refractive index is the speed of light in vacuum by speed of light in that medium. So a greater value of mu implies a smaller value of v. So for a violet light, the value of the velocity in this particular refractive medium will be smaller than that for red light. So the cause of the dispersion is the different speeds of light inside the prism. Outside the prism is air and all of them travel with the same speed. But inside the prism, since it is a refractive medium, the one with the smallest velocity, that's violet, is deviated the most, and the one with the lowest refractive index, that's red, has got the highest velocity and so is deviated the least. And this difference in the wavelengths, the difference in their speeds, leads to the dispersion. Remember one thing, if you are asked this question that at which surface of the prism dispersion happens, dispersion always happens at the first surface of the prism. Refraction takes place in both the faces of the prism. Refraction takes place at the first surface as well as the second surface following the Snell's laws. But dispersion only happens at the first surface. In the second surface, the 7 different lights, they travel as 7 individual rays of light and they emerge out of the prism following the laws of refraction. Refraction and deviation in the light rays happen in both the faces of the prism, but dispersion happens only in the first face of the prism. Thank you.